Happy Zappi! Today is all about a Zappi wall charger installation that I've recently carried out. As always guys, if you enjoyed this video, hit a thumbs up and don't forget to subscribe to the channel if you haven't done so already, because I post regular videos here all about the life of an electrician and electric vehicle charging installations. Thanks for watching and enjoy the video. Good morning guys. So I'm installing a MyEnergi Zappi charging point today, and it's a tethered one. It's the version 2, which is the latest version, and they're really cracking bits of kit these, so I'm looking forward to installing it. It's going to go up on the garage wall here somewhere. We've got an existing garage consumer unit here, but unfortunately it's not strong enough. The supply cable to it is not strong enough to power the charger, and we've already got sockets and lights running off of it. Not that they're running a huge amount off here, but it's only a 16 amp supply and it's a 7 kilowatt charger that's going in, so we won't be able to use the existing supply here. So what we're going to do is run a separate armoured cable from here down the wall. Charging point's going to go on the wall here somewhere. Armoured cable down the wall through to the other side. Then this is the other side of the wall. You can see here we've got the existing armoured cable coming through, so it'll probably come through somewhere next to that. Run it down in this little gravel strip along here. I'll just dig up a bit of that gravel along there. I'm going to take up a couple of these slabs here, run it under these slabs, and then I'm going to just run it around the outside of the house here, under the just along the bricks, under these existing telephone cables, along to just after where the gas meter is, and then just going to drill in, and the meter, electric meter and consumer unit are just the other side of that. Now the great thing about these MyEnergi Zappi charging points is that they don't require an earth rod, so they've got built-in pen fault detection, and MyEnergi have actually invented their own technology which they've patented, which nobody else out on the market has got, that enables them to do pen fault detection not just based on voltage, which if you've seen the eFix video out there you will know that there is a potential issue with voltage based measurement for pen fault detection. So inside the MyEnergi charger it's got CT clamps which measure various earth leakages and various voltages in order to detect if there really is a pen fault or not. So the great thing about that is no earth rod to worry about, even though it's a TNS PME system. Also nothing to worry about with regards to simultaneous contact of conductive parts outside, so we don't have to worry about that. We can literally just wire it straight off the house consumer unit. Going to be wiring it in armoured cable clipped direct, so we're just going to wire it off an MCB in the existing house consumer unit. 40 amp MCB, armoured cable clipped around up to the charging point and in, so it should be a fairly straightforward installation. And the great thing about these charging points is that they are very smart. So the Zappi particularly has features built in for solar integration. In this property we don't have any solar at the moment, but what it can do is it can measure the input from the solar panels, and it can direct that the charging point only charges the vehicle when there is input from the solar. So essentially you're charging your car on sunshine, free electricity, which is amazing. And the other great feature that it has is because of the CT clamps that are part of the installation, you can make sure that you're not overloading the main fuse of the house. So if it's only a 60 amp main fuse, you don't need to notify the DNO before the installation, because you can have this kind of load management system set up within the charger that it will never allow the installation to go over the maximum 60 amps that is the capacity of the main fuse. So all in all, these Zappi chargers are really great, and I'm going to be installing them as standard for most of my jobs now. So I'm looking forward to getting stuck in and installing this, and I'll let you know how I get on. So armoured cable is going to run along here along there, and just near where the gas pipe goes in, it's going to go into the house, and the meter box and consumer unit are just on the other side there. So I'll just show you in here. It's quite unusual to have the meter box inside the property. I'm not quite sure why they did it that way, but that's the way it is. So we've got a PME system, as you can see here from the main cutout fuse. It's a 100 amp main fuse, so we don't need to worry about supply capacity anyway, really. But we've got a isolator, which is good. So that enables us to isolate the whole consumer unit while we do the installation of the new MCB. And as you can see here, we've got a spare slot on the non-RCD side of the board. So I'm going to put a new 40 amp MCB in there, type B, and then run the new charging point circuit off of that. What I'll probably do is run the armoured cable down here, clip it in the corner there, and then just drill through down at an angle to come out on the other side, just on the bricks, and then clip it along. And I might be able to just terminate the armour directly in here if there's space inside. I'm going to take a look at that now, take the cover off and see what we've got. Okay, so we've got a nice free bit of buzz bar there. I was slightly worried that they might have cut the buzz bar short, so I did bring a spare piece of buzz bar just in case, but that's good. In terms of loads here, we've got a cooker circuit, 32 amp, we've got 2 rings, and we've got what seems to be smoke alarms, upstairs lights, downstairs lights, water heater, so that'll be the immersion heater, and then the garage circuit, which, as I said, is just 16 amps, and it's only on a 2.5mm cable, so it's definitely not strong enough for us to run the charging point from. We've got space here that we can terminate our armoured cable just in the bottom here with an earthing nut, and then just run it down and pop through the wall there, so that's going to be perfect. So one of the things we obviously have to do is check the main bonding, and this is the gas one, so I thought I'd just have a little look, and it's a little bit loose. So what I'm going to do is just re-terminate that. It looks like it's a little bit corroded with the weather as well, so I'm just going to re-terminate that, probably put a new clamp on it, and then it'll just make it a bit better, a better connection there. I need to go and check the water now as well. So we've got the main stopcock here for the water, and it is earthed. We've got an earth cable there, so that's all good. So another great little feature of these things is this wall template for the fixings. So you can literally just hold that up against the wall and then mark your fixings, drill them out, and they'll all be in the right place. So I'm just going to do that now. I've got my Sharpie, well, it's not Sharpie, it's a Pica pen actually. I'm just going to use that Pica pen to mark up these holes, make sure that they're all level, and then I'm going to drill the fixings and then run the cable down from this end, run it back to the house. So safety first. I've got my safety glasses, ear defenders, respirator, so I'm not going to get silicosis from all the brick dust. Let's get started. So inside here you can see some of the gear that's going on here. Now this has got a built-in Type A RCD. Where is it? Well, it's actually hidden within the circuitry here, but it has got a built-in Type A RCD, and it's also got 6 milliamp DC protection as well. So it means that as long as the cable feeding it doesn't need RCD protection, then you don't actually need to provide an RCD at the consumer unit. You can put it on an MCB. Now this is a single phase version, so we've just got live L1, neutral, CPC. And some eSense terminals which won't be used by us, but they can be used if you've got kind of a special meter that you want to connect it to. Current transformers, CT1, 2 and 3, can be wired in directly to this, but we're going to be using the wireless Harvey, which will communicate with this wirelessly rather than hardwired, because we don't want to have to run CT wiring from here all the way back to the house as well. And these essentially are contactors which cut off the power to live, neutral, CPC, completely isolate them in the event of a pen fault, which is what's required now by the regulations. So that's why we don't need an earth rod. So I'm going to get this up on the wall now and then start running the cable in. So these are the fixings that are provided. So you've got 4 screws, 4 washers with rubber backs, which are to maintain the IP rating, 4 brown plugs, and then these 4 little screws, which I've not figured out what they're for yet. But basically the importance of these rubber bungs cannot be underestimated, because they maintain the IP rating. So you've put them on there like that, and then you use these nice stainless steel screws that they supply just to fix that back, and that will maintain the IP rating. Now you've only got 4 and there's 5 holes, but they do supply these little rubber bungs to go in the hole that you don't use. So it's important to fill in a rubber bung in the one that you don't use in order to maintain the IP rating of the casing. Okay, so I've got it on the wall now with the washers, and see the one in the middle here I've not used, so I've got the bung on there. These are nice and tight and they seal the whole thing. It's indoors anyway, so it doesn't really matter in this case, but usually it's very important to maintain the IP rating of the casing. You can see it's got a nice seal all the way around here, so this is designed to be able to be used outdoors, to be able to spray it with a hose or whatever by mistake, or it rains on it and it doesn't get wet inside. So now what I'm going to do is drill a cable entry hole in here, then I'm going to run the cable down from here and then along to the corner, and then drill through from the corner, and that'll take me out exactly in that little channel that I've cut on the other side. So recently somebody told me about these, the SWA storm glands. They're basically a different type of steel or armoured gland which are sort of combined with the compression gland, so there's no shroud, and they essentially make it quicker and easier apparently to terminate steel or armoured, and they're more IP rated or something. So I'm going to give them a go today and see how I get on. So basically, see what it is, you've got a compression part, which is this, and then you've got the metal armoured part, which is this. So I guess you just slide the whole thing over the armoured, tighten it up like that, and that gives you your earthing. They supply these ones with earthing nuts as well, which is quite handy. Yeah, they look interesting. It's going to be cool to see how they actually workout. They give you a couple of little crimps and things in there as well. Assembly instructions. There you go. So let me know in the comments if you've ever tried these and how you got on with them. Okay, so what I've done is just dug a little channel out here. I've removed these slabs, dug a little channel which will get us a route to the wall here from the garage, and I think what I'm going to do is just drill straight through here from the other side at an angle, so I can come out here and just run the cable straight along. There's slabs above this, so there's no chance that anyone's going to be digging there and hitting the cable with a spade or anything. It's got sand around it to protect the cable, so I'm happy with the depth of that. I'm not going to try and put it 18 inches under or anything like that. It's impossible. So I'm just going to put that under those slabs, and then it'll be obvious anyway that the cable's going through there, because you'll see it going through the wall on the other side, and you'll see it popping up here on this side. So someone would have to be pretty stupid to be digging around there. Okay, so I've just drilled through here at an angle, as you can see down in the corner here, and I've come out exactly where I wanted to be, so that's perfect. So now I've got my pilot bit through. All I need to do now is put a larger drill through at the same angle, and that'll open up the hole wide enough to get it exactly where I want it to be. still a bit more. That'll do. Perfect. Okay, so I've got my armoured cable terminated into here, and that's all ready to connect. Armoured cable clips down here, around and through the corner there, and then I managed to come out in exactly the right place down there, run it underneath the slabs there, and I've put those slabs back now. And then it's going, I've just clipped it up, going along all the way around here. And now comes the crunch time. So what I've got to try and do is run it down, drill at an angle from the inside and come out in that corner there. So let's give it a go. Okay, so I had to butcher it around a little bit. It was a bit tricky, but I drilled a pilot hole through and it went slightly too low, went under the slabs on the other side. So I've just changed the angle slightly and using a bigger drill bit so I don't go in the same hole as before. And let me show you. Voila! That'll do. I would have liked it if I'd have come across slightly more, but that'll be fine. So quite pleased with that. It was a bit of a tricky angle. There was plasterboard on the other side as well with like a void for the meter box, which I hadn't thought about, so that made it even more tricky to drill. So happy with that, and I'm gonna get the cable through now. What is it with being an electrician and being stuck in small cupboards? Actually, this one's not too bad. It sort of human's width, so it's okay. But I'm just gonna terminate this armour now. So what I've got to do is clip it up the wall, just behind me here. There is a wooden joist behind the plasterboard, so I can just screw to that, which is good. And then I'll clip it up about halfway, measure it off, gland it, and then terminate it into the board. Got these new Armeg screwdriver bit things, and they're actually really good. They're magnetic, so I'll show you. It's not going to work for me now. Okay. Yeah, so the screw just magnetizes on, and it's super strong, so it's quite handy. Because I always end up dropping screws, which does my head in. Okay, get that as flat to the wall as we can. And I'm just going to measure this whole length, roughly 1 metre, 1.4 metres. If I do 30 centimetres, 3, 6, 9, 12, and that gives me 20 centimetres space before the last clip, so it should be fine. 1, 2, 3. Yeah. See what I mean? So I'm actually really liking these storm glands so far. They're easy. They're easier than a normal gland. Let's face it, time is money, so it's all about actually saving yourself some time and some hassle. So the only thing is, the ones that I've got are slightly too big for this cable. The compression part doesn't really clamp down that well on the sheath of the armoured, so I might have to get a slightly smaller pack next time. I'm not sure how they size them exactly, but yeah, they're just really easy to fit, and they look smart as well. They look smarter than a normal armoured gland. Good old armour slice tool. I was a bit sceptical about this at first, but I only use this now. It's just, you've just got to get the knack of using it, because it's gauging how tight to do it. If you do it too tight, then it can end up bending the armoured steel wires around rather than cutting through them. So you just need to be careful about how you tighten it. But it's one of those things you just get used to the feel of it, and after a while it's kind of second nature really. So it's fine, and it just gives such a nice smooth cut. Probably need to change the blade on this soon because I'm still on my first blade. I've had it about a year now, so not that I use it that much, but so what you have to do with these is just undo the compression part. So you've got a brass ring in there, you've got this part here, slide the compression part down the armoured, and strip off the sheath. I think while I've been away, some moisture's got into my van or something, because a lot of my tools are kind of getting a bit rusty. Don't really know how you can avoid that though. So you see how it does such a nice clean score around the armoured that you can just wiggle it around a little bit and then all the armouring comes straight off. Slide that off. Then I'll do this part afterwards. But what I can do is just, you can strip the outer sheath back quite far with these glands as well, which is good, so you get a bit more of a wide display on the actual armouring, which is sometimes difficult with normal glands. So now we just marry that up as tight as we can. There you go. And then get the grips on it. Basically just looks like a big version of the compression gland that you would usually use for a non-armoured cable. So that's the armoured bit tightened, and then the compression bit. Mostly you can just do it by hand. That's it, really. Easy as that. And then we put an earthing nut on there. It's got a little plastic sort of rubber washer here as well to keep the seal on the outside of the enclosure, which is nice. Again, I'm doing this indoors, so it doesn't really matter, but it's just for neatness and just to practice with these really. And then what I do is use this, just leave about a couple of centimetres there, score around that. Actually use this part as well to just score down. There, and then that just peels off. Really. There you go. Easy as that. So now what I'm going to do is drill a 20mm hole in here and then gland it inside the plastic enclosure. But before I do that, I'm just going to isolate the power to this, so I'm going to do a safe isolation procedure now. So before I start connecting the armoured into the consumer unit, I'm going to isolate the whole consumer unit by turning off the main isolator in the meter box down here. And of course I need to make sure I prove that it's dead before I start working on the consumer unit. So first of all, I'll just check that my tester is working. So I've got power here, live to neutral, neutral to earth, live to earth. Now I'm going to isolate the main isolator. First of all, I'll just turn off all these circuit breakers one by one, and I'll do an RCD test as well while I'm at it. Main isolator off, and then the supplier's isolator here, and then I'm just gonna check no power there, neutral to earth, live to earth, and then I'll just check to make sure my tester is still working correctly by using my proving unit, and that's working fine. All good. So now I know that I'm safe to work on this. Now I'm not going to lock it off because I'm literally working in this cupboard myself. There's nobody else around, so I'm just going to beaver away and get this done. These earthing nuts are brilliant. They are expensive, but massive time saver. Oh man, I hate working in cupboards. Shouldn't be an electrician really if you hate working in cupboards though, should you? Alright, good. So we've got flying lead here. Just going to crimp that. On the other end I've got a ferrule. I'm going to use ferrules on this. I never usually use ferrules on armoured cable, but I figured, hey, why not? And then I'm going to connect that in to, in fact, I'm going to tuck that down there first. Like that. The other end will go in here. 1, 2, 3, 4, 5, 6. So that will go in there. Actually, I think I'll put the main earthing conductor for the armoured in there, and then here I'll just do this as like a bonding conductor, as there is no circuit 13. I'll just connect it in there like that. Then I need to remove this buzz bar, like so, and then pop my new MCB in there. Great, they're always slightly different size, but it's the same as those, so it should be alright. Just annoying. Now the torque on this is 2.3 Newton meters. So once I've got all these loosely tightened up with my normal screwdriver, I'm going to go over them with my torque screwdriver. Let's check all those teeth are in properly, and they are. So I've got my torque screwdriver here set to 2.3 Newton meters, and I'm just gonna go over those. It's surprising how 2.3 Newton meters doesn't feel that tight actually. It's probably looser than I would usually do it. Check all the other terminals while I'm here. It's always good practice to do that. Yeah, some of them are quite loose actually. Okay, so live conductor. Thread that through here. I like to leave a bit of slack in the board if there's space like there is in this one. So that'll do it, I think. And again, what I'm going to do is put ferrules on these. Slightly too long. That's that. So what we got here? 6 mil. Maybe not. Let's try that one. That feels a bit better. Good stuff. Now these need to be identified, so I'm going to put some green yellow tape on the black to identify it as the circuit protective conductor. do. Then some blue tape on the grey to identify it as the neutral conductor. Now for some reason these are not synchronised. They've done it slightly weirdly, so I'm going to shift those across. So these two should be together, basically. Just get my needle nose pliers. Annoying when they do that. Those two should be together. Like that. And then this one. These can all shift across there now. Actually, that's not right, because you've got two here, so you've got two here, which is these two. It's the wrong way around. Why can't they do the board the right way in the first place? Right, so that will go like that. And that one in there. So at least they're all in the right order. Okay, so everything's connected in now. Neutral's in there, earth, live, bars in, everything's torqued up, that's earth. So what I'm going to do is go to the other end now, run a few tests from the other end. So I'm going to do R1 and R2 test. I'll just link it out that end and then I'll come and test it at this end. Then I'm going to do insulation resistance, and then I can get it connected in the other end and liven it up, and then do a loop impedance test. And I'll need to do Z, E and PFC here as well, which I'll do in a bit. So I've just stripped the wires to the exact length that I'm going to keep them at now at this end, and what I've done is just shorted out the line and CPC conductors using my crocodile clip here. So I'll go to the other end now and just do a continuity test to check that we've got continuity of CPC. Right, so I've got my line and CPC conductors looped out at the other end, linked out at the other end. I've zeroed my leads, and now I'm just going to do a continuity test. We've got 0.07 ohms on there, so that's perfect. So I'll go and unlink those now at the other end, and then I'll do an insulation test. Okay, so everything's unlinked now at the other end. So I'm going to do an insulation test and see what we get. So we got 80 odd meg ohms neutral to earth, which is surprising but good, because that's the whole installation there. Live to earth greater than 200 meg ohms, and live to neutral should be the same. Perfect. 0.29 earth loop impedance, very good, very low. That's why they call it a happy Zappi. It makes happy noises. Okay, so I've got my Rolex charge check unit here. Now, MyEnergi do their own version of the testing unit, but this happens to be the first one that I bought when I started fitting Rolex charging points, and it works, so I'm just going to keep this one for the moment. But basically it's a contactor box that's got a test button that activates the internal circuitry, and you can check the polarity, and then you can run a loop test on here and an RCD test, so I'm going to do that now. So I've got 0.89 for earth loop impedance, which is, obviously going through all the circuitry and stuff, and it's a non-trip test. Now I'll do RCD time. I'll do the auto test and see what it comes up with. So half times is greater than 200, greater than 200. 1 times 99.8, and we'll do another. Again, it's tripped 100.8 milliseconds. So we'll hold for 3 seconds. It's going to reset again. And then 5 times test. 27.3 milliseconds. Right, so the Zappi is in and looking rather nice, if I must say. Everything went in fine with the cabling and the connection at the other end, so I'm pleased with that. So now I'm just going to do the setup, which involves connecting the Harvey and connecting the hub to the Zappi. So I'm just going to go through that now. A very important note here is this. This is the Zappi communications hub, and this doesn't come as standard with the Zappi, but it's essential if you want to claim the OLEV grant, because in order for the Zappi to be a smart charger, it needs to have this wireless communications hub. So this plugs into the home router, the Wi-Fi router, via an RJ45 plug, which is supplied with it. It plugs in there. It needs power as well, so you need a power socket and a spare RJ45 socket in the back of your Wi-Fi router. This plugs in, and then this communicates wirelessly with the Zappi in order to connect it to the internet and make it a smart charger. And you need to take a picture of this in order to send off for the OLEV grant to prove that it's a smart charger. You have to not just take a picture of the charger itself, the Zappi, but you need to take a picture of this as well. So just a little heads up there. So this is the Harvey, and this is the device that you use to connect wirelessly the CTs, and the CT just very simply wires into here. So there's a little cover on the back which you just remove. There's these little stops, which I've removed one already to allow the cable to go in. So you just push the cable through there, and then they've got these simple push fit connectors. I'm only using one CT, so I'm just going to connect it into CT1, and you just push these little connectors down, just slide the wires gently into the terminals, give them a little tug to make sure that they're secure, and then I'm going to fix this back to the backboard in the meter box, and then just click that in place. So I've got the Harvey fixed in place here now, and this is the CT clamp, which I'm going to put onto the live conductor. So the finished product, new circuit is in, Harvey is in, and the CT coil is done, so that's sending the signal for how much power is going to the grid. I've set it to 90 amps so that it'll never blow the main fuse. Just tidied up that CT coil cable as well with a cable tie, so that's nice and neat. And then we've got the armoured cable running down through the wall. I filled in the hole there, so that's nice and neat. Then new bonding clamp on there, silicone to seal up the hole, and then the cables running round here under the pavement through into the garage, along and up to the Zappi, and that is all up and running, ready to go. So I hope you enjoyed that video. If you did, please hit a thumbs up. It really helps the channel to recommend the videos out to other people who will also enjoy them. And if you haven't done so already, subscribe to the channel, because we post videos here regularly. And if you hit the notification bell, then you won't miss out. Also, have a look at the links in the description, because I've got some great deals for my subscribers about some of the tools that I use, and also you can get 50 quid of free electricity and gas from Bulb. So check out the link in the description below. Thanks for watching, and have a great day.